Okay, so let's get started. So as we said, we define a class with the 4 functions required of the design document. First, we import codecs because we're going to use it as a string object to decode the message in the decryption function, and using the Unicode code, and also the collections counter to use this as the frequency letter function. So basically we have defined the class and we have the functions where in initialize we define the length of the key, and then in the range we define the state in 256 bytes, initialize the index pointer, and then in a range of 256 we establish and swap the values of the state using the key and the state and the index pointer as defined as the standard. And also for the next code we define and we initialize the 2 pointers, and then we establish the first one that this is defined as the standard also, and I define a additional function of key string which initializes the key and then uses and that returns the next code, which is the key string we're going to use. So for the XOR code, we transform the key into its Unicode value for each character in the key, and then we call the key string function passing the key, and then we create a initialize an array to append it in the value of the XOR. We're going to use an XOR of the character with the next key string and taking the hexadecimal value and appending it on the array, and then we return that. So for the ENCDEC array I define 2 types of functions, encrypt and decrypt, for clarification of the functions. They're just the same. They convert the whole array in bytes and return the whole array of decryption or decryption. Doesn't matter. And for the function of frequency letter function, it just counts the frequency of the letters in the text passed. So basically here as a test I define as the 2 objects, and yeah, so I store the string input of the key in the variable key, and then I define the array as here. I did it like this because it's not required to convert the string into an array of bytes, because it's done here. It's done as here in hexadecimal codec using the codecs and the decryption, and for the decryption also. So then I store it in the A1, and then I encrypt it using the first object, the encryption, and then I print it. Then for the decryption I pass the encrypted text, and then I decrypt it, and then I print it, and then I print the frequency letters. So basically I pass when I run it. So this is the initial permutation of the state after and before the permutation. Yeah, this is the permutation. Yes, to demonstrate the states. This is the initial, and these are the before, the before and after the states, random states. This is the before, after, and so forth of the random generation of the bytes using the pseudo of the next code here. This is generated here on the next code. So this is all the states which is passed throughout this one. I use this key and the plain text of good work. The implementation is correct. And these are this is the initial. permutation, and these are the before and after states. So this is the ciphertext. This is the 256 bytes of ciphertext, and then it's also passed along the way for the decryption, which are the same. And this is the decrypted text here. So this is the frequency of the letters of the bytes. So here you can see that this is in hexadecimal values, to be clear. And it says that 2 it's appeared in four times, the deeds 6 times, 7 6 times, and so forth. So you can see that the frequency is very large. It's more than 1 in every one. That's why one of the reasons it's so insecure, that you can guess what bytes are if you know the algorithm, right? So this is the demonstration. Thank you very much.